All right, guys, let's talk about the strong titration. So we will have 40 milliliters of 0.1 molar HCl is titrated with 0.1 molar NaOH. Okay, so our analyte, which is in the flask, will be our 40 milliliters of our 0.1 molar NaOH, right? It's known for the purposes of teaching, right? And then our titrant will be our sodium hydroxide. All right, so point number 1, find the pH at the following points before any sodium hydroxide is added. All right, so the initial, okay, so number 1 is the initial. Well, so the concentration of HCl equals the concentration of H3O plus. Why? Because it's strong acid, right, as we've learned. So that means the pH is equal to the negative log of hydronium. So our pH is equal to the negative log of 0.10. So our pH is 1. pH is 1. All right, so now, part 2. 20 milliliters of sodium hydroxide is added. So our volume is changing now. That makes sense? So in these, our volume changes. And that's important. That's a horrible G. There we go. All right, so I'm going to find the moles of HCl. So we have 40.0 milliliters. And we know for every 1,000 milliliters, we have 0.10 moles, right? Which is 0.004 moles or 4 millimoles of HCl. Millimoles, if you guys remember, molarity is moles per liter. It's also millimoles per milliliter, right? So sometimes it's easier to work in millimoles because we don't have all those zeros. But you can do it either way, all right? So we're going to always start with 4 millimoles of HCl. Now, sodium hydroxide. We have 20 milliliters. So for every 1,000 milliliters, we have 0.10 moles. So it gives us 0.002 moles, or not 4, 2 millimoles of sodium hydroxide. All right, what is our net ionic equation? All right, so our equation is HCl plus sodium hydroxide going to sodium chloride and water. Right? If we were to do this, our detailed H plus, Cl minus, Na plus, OH minus, Na plus, right? So all these so far are strong electrolytes. Right? Strong acid splits apart. Strong base or ionic and aqueous splits apart. Salt, ionic and aqueous, so it splits apart. Liquid stays together. So our net ionic equation, I would just have the H plus, I have the OH minus, going to H2O liquid. So there's our net ionic equation. And we're starting with 4 millimoles of H plus and 2 millimoles of hydroxide. All right? Or 0.004 and 0.002 moles, however you want to do it. Well, the limiting reactant is hydroxide. So we're going to minus the 2 millimoles, minus 2 millimoles, and nothing on the product side. So at the end, we have 2 millimoles of H plus in the solution and no hydroxide. But now the new volume, right? We started with what? 40 milliliters from the HCl, right? And we're adding 20 milliliters from the NaOH, right? So that means our new volume is 60 milliliters. All right, so if we have 60 milliliters, we have 2 millimoles, so we'll take our 2 millimoles of H plus and divide it by our 60 milliliters. Now, just note this is the same thing as 0.002 moles divided by 0.0600 liters, right? Same thing. And we're going to get a concentration of 0.033 repeating. All right. So then our pH, negative log of 0.033, which is 1.48. All right, so that is 2. So we got 1 here. Where's 1? Let me just get my highlighter out here. There's question 1. There's question 2. Might as well just do this. All right, so this is 2. This is 3. Now we have 40 milliliters of sodium hydroxide. Well, if we have 40 milliliters of sodium hydroxide, so for every 1,000 milliliters, I'd have what? 0.10 moles. 0.004 moles or 4 millimoles of hydroxide. Back to the same net ionic equation. H plus, OH minus, going to H2O. Now I'm going to go to 4 millimoles of H plus. I always go back to the original. Why do I go back to the original? Well, if we made a mistake here, let's say we made a mistake in this. 4 minus 2 is 6 or something like that, right? Okay, or we've all done things like that. It happens, especially on a test and there's pressure and your mind does these things. Sometimes. Maybe you've never done it. I've done it. I've done stupid, 3 times 2, I've done it as 5. It's not 5, it's 6. But we've all done, or most of us have done stuff like that. So if I go back to the original, if I made a mistake in this region here, it's not a big deal, all right? Okay, it's a mistake for number 2, but it's not necessarily going to be a mistake for number 3. The error here does not propagate down, right? So I always go back to the original up top and start with the original number of moles. For hydroxide, we also have 4 millimoles. So that means, they're minus the 4, because there's no limiting reactant here, so there's 0. So this means concentration at H3O plus equals the concentration of hydroxide. That means the pH should be 7 in theory. That's the pH of the equivalence point. All right, so this is equivalence. All right. And I'm going to, well, we're just going to do that. We're going to down to 4 here down here, which is past equivalence. And it's 60 milliliters this time, right? We have 60 milliliters of sodium hydroxide. So we have 6 millimoles of hydroxide. H plus, OH minus, water. So I'm going to go back to 4 millimoles of H plus, 6 now millimoles of hydroxide. Who's limiting now? Well, H plus is -4, -4, none, and we're left with 2 millimoles of hydroxide. New volume. We started again with our 40.0 milliliters of our HCl, and we got 60 milliliters of our NaOH. So that means our new volume is 100 milliliters. All right, so we have 100 milliliters. We have 2 moles. So that means our concentration of hydroxide will be our 2 millimoles over our 100 mill. Oh. So that means we had to have what? 0.02. Now, how are we going to get the pH? Because this is hydroxide. So if we remember, pH plus pOH is 14. So the pH would be 14 minus the pOH. So the pH would be 14 minus the negative log of hydroxide. So the pH is 14 plus the log of 0.02. So it means the pH would be, I got 12.3. Right, so those are the 4 regions of a titration and an example of calculations of each region for a strong titration. Right, so past the equivalence, the pH is due to the excess hydroxide present, right? It just depends on the volume, and you get the pH. At equivalence, I didn't highlight that. Equivalence, right? The equivalence of strong should be neutral. Before equivalence, right? The pH is due to excess H plus, so it should be below 7 as a pH if we have a strong base in the burette and the strong acid in the flask or beaker as the analyte. And then the initial is just the pH of a strong acid. All right, so that is the calculations of strong. If you have any questions, reach out. Otherwise, we'll see you next time.